Here we are in section 7-4, exercises 1 through 12. Name the number sets that each number fits into. Here's our little diagram. Remember, if you're like in the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whole numbers include a 0, so if you're in natural, you're also in the wholes. If you're a natural number, you're a whole, and you're an integer, which includes like -5, -10, -15, but it includes all the natural numbers as well. The Q is the rational numbers. That's all the fractions inside the real numbers. Here are the imaginary numbers over here. So if you're rational, you're not irrational, but you are real. And that's what we had back in chapter 1. Now we've included imaginary numbers, square root of negatives. And if they're imaginary, just purely imaginary is out here. And if they have both a real and an imaginary part, they're complex. So imaginary numbers are complex, real numbers are complex, they just have 0 for the other component. So let's go through and we'll try to use colors to map it out. So number 1, square root of 12. That's a square root that doesn't come out nicely. So that is smack dab in the middle of irrational numbers. And so that is going to be a real and a complex number. Ooh, that didn't come out very nice. There we go. There we go. Okay, so irrational with is just the I. Good. Next one. Let's try number 2, square root of 121. Square root of 121. That comes out nice and is just the number 11. So notice it is right here. That's a natural number, a whole number, because if it's natural, then it's whole, and it's an integer, and it's rational, which means it is real, and everything is complex. So that is all of these fit in. It's not irrational, it's not imaginary. All right, number 3. 5 plus 3i. Notice that this is this has an imaginary component, which it has here, but it also has a real component, so it's bridging this gap. So the only thing that it is, it's not purely real and it's not purely imaginary, so it is only complex. There we have it. Number 4, this guy right here, 5.234, 234, 234. It repeats that pattern, which means if it's a repeating decimal, it is a rational number. So it is not integer, whole, or natural, but it is rational. So let's put that one in. It's a rational number, which means it's also within the real numbers, and which is within the complex numbers. Good. Number 5 is -13. All right, let's look and see what that is. -13. So -13 is a nice, there's no fraction, no decimal on it, and so that's an integer. So that's an integer, which is inside the rationals, which is inside the reals, which is inside the complex. So we get those 4 sets that -13 is. Okay, next one, number 6, square root of 73. Square root of 73 is a square root that does not come out nice, so that is irrational. So that's going to be the irrationals, which is inside the reals, which is inside the complex. Okay, number 7. I square roots of 7. So this right here is a purely imaginary number. There's not a real component like on number 3. It is just imaginary. So it's not even in the real numbers. So it's none of these guys right here. It is squarely there, which is part of the complex numbers. Good. Number 8. We're going to do pi squared. So remember, pi is one of those irrational numbers. And pi squared is no better. So it is irrational, which is inside the real numbers, which is inside the complex numbers. All right, number 9. Number 9 is square root of -900. So square root of negative is I. Square root of 900 is 30. So this is 30i. This is squarely an imaginary number. There's not a real component. Notice up here it had a real 5 and an imaginary 3i. This has just a purely imaginary piece. So this is imaginary, which is part of the complex numbers. And you'll notice complex happens on everything. That is correct. All right, the next one, number 10. 0 divided by 17, that equals the number 0. And so 0 is not natural, but it is a whole number, which means it's whole, which is inside of the integers, which is inside of the rationals, which is inside of the reals, which is inside of the complex. Good. All right, the next one. The number square root of 1,000. That doesn't come out nice. You wish it would because it looks like such a nice round number, but that is 10 cubed. So it could be simplified into 10 square roots of 10, actually, if it's square root of 10 times 10 times 10. But this does not simplify down, so it is squarely irrational. Wow, look at those irrationals that we got. So that is irrational, which is inside of the real numbers, which is inside of the complex numbers. And number 12. Negative 53.741. That's a decimal that terminates. If it stops, then it's a rational number, which is right here. So it is rational. Notice it's not an integer because it has a fraction part. So it's rational, which is part of the real numbers and which is part of the complex numbers. Now I want to note that this is part of the complex numbers because it's negative 53.741 plus 0i. Same thing happens with all of these real numbers, that they really, this is negative 13 plus 0i, 11 plus 0i. So all the real numbers fall inside the complex numbers, and all the purely imaginary numbers fall inside the complex numbers. Good.